Kia ora, Year 12 and 13. This is the 2010 Scholarship Calc paper, question 1b, and it's a question with two little equations. We're asked to find all real values of x which satisfy this set of equations. So the first one is sine of x equals root y. The second one is a cubic in y, which equals cos squared of x. So I'm going to start by rewriting that first one as sine squared x equals y, and I'm going to use this in here. And we're told to start by finding possible values of y. Now, I did this a slightly different way from how the schedule does it. I'm going to go through what I saw, but you might find other ways again. So I looked at it and decided to substitute in sine squared. And I think the reason my brain did that is because it sees a cos squared and it sees a sine squared, and it wants to do something with cos squared plus sine squared. And that turned out to work reasonably well. So this first one we've looked at, and now we're going to substitute y into here. Right, so we get 12 y cubed is going to be sine to the power of 6x, okay, minus 13 sine to the power of 4x, minus 14 sine squared x plus 13 equals cos squared of x. Now I'm going to come back and rewrite that as y in a couple more steps. So we're not going to work with an equation with sine x to the power of 6. But for now, what I looked at was I've got cos squared here, and I've got minus 14 sine squared x here. Now I can think of that as minus 13 sine squared x minus another one. So that gave me 12, actually I'm going to put it back to y now, sorry for the confusion. So 12y cubed minus 13y squared minus, well I've got minus 13 sine squared x, so that's going to be minus 13y plus 13 equals cos squared x plus sine squared x, right, which is going to give me 1. So that means that now I've got 12y cubed minus 13y squared minus 13y plus, well if this is 1 here, then I've got plus 12 equals 0. Now suddenly that equation doesn't look too hideous at all. I'm going to go to a new slide, but if we're going to factorise a cubic, especially one that's got lots of 12s and 13s in it, we probably want to use the factor theorem and do some intelligent guessing and checking. So that's what I'm going to do next. Right, so I'm going to call this thing p of y, and this is 12y cubed minus 13y squared minus 13y plus 12, and I want to figure out when that polynomial equals 0. So, well, we're going to start with 1, right, because that's where I started, and it turns out not to work, but it gets your brain going. So if we substitute in 1, which would mean y minus 1 was a factor, we'd have 12 minus 13 plus 12, right, which is equal to negative 2 is not equal to 0, so we have a sad face. But we're on the right track, so now we're going to try substituting in negative 1. In other words, we're seeing if y plus 1 is a factor. All right? So y minus 1 is not a factor, but maybe y plus 1 will be. Right, so we get 12 times negative 1 minus 13 times 1, because negative 1 squared is 1, minus 13 times negative 1, so plus 13, plus 12. And look at that, we've got negative 12 plus 12, minus 13 plus 12 equals 0. So y plus 1 is a factor. And that means what we're going to do now is we're going to do long division on this to figure out what's the quadratic that's coming out of that. So I'm going to do that on a new slide just because we know that's going to be long and messy. Okay, so here comes the long division. Sorry, slight interruption there while I try to get my kids to be quiet. Right, so 12y cubed minus 13y squared minus 13y plus 12. Now, if you're confident with this, you can just pause the video, go off and do it, and come back when we get to the end. But if you're not, you can watch, right? What we're trying to do is match things up. So we want to say y times what is going to give me 12y cubed. So it's going to be 12y squared, all right? And so then I go 12y squared times that. So I get 12y cubed plus 12y squared. Now there's another video on long division if you haven't done this before. Now I'm subtracting this from the top line. So I get negative minus 13y squared minus 12y squared. So minus 25y squared. I bring this down, I get minus 13y. Now off I go again. I'm saying y times what is going to multiply to give me that. So I have minus 25. It's very hard writing at the top of the iPad screen. There we go. Minus 25y. Minus 25y squared minus 25y. So when I subtract this time, I get minus 13y minus negative 25y. So that gives me plus 12y. And this is starting to look quite good because I've got 12y plus 12. And so I'm going to have a plus 12 up here. Right, now we know that it has to work out that I get a remainder of 0 because we've already used the factor theorem and found that y plus 1 is a factor. So what we've got now is we've got, I'm going to go to a new slide to do the next step. Alright, so here's where we're at. We're trying to factorise this. We've got 12y cubed minus 13y squared minus 13y plus 12. And now we've got it down to equals y plus 1 times the results of our long division, which is 12y squared minus 25y plus 12. So what we've got to do now is factorise this. So that equals y plus 1 times something something. Now I know some of you are probably going to reach for your graphics calculators, but hopefully if you're doing the scholarship exam, you're going to look at this and you're going to try and play with it before you do that. Okay, so we're going to try out a 4y and a 3y, just because it feels like that's going to work. And I'm going to have a minus and a minus, so I'm looking for a combo of numbers that's going to add up to give me negative 25. Now you've got a 4 and a 3, so you might be thinking somewhere deep in your brain about Pythagoras. So there's a 16 and there's a 3, so 16 and 9. Let's see if that works. So I've got 4y times 3y, 12y squared, minus 9y, minus 16y, plus 12. Of course, it's completely fine to factorise that on your calculator and get the roots that way. But most of you watching this will probably do that one by hand. So now we've got that, and we can write down, whoops, wrong, that's not the eraser, that's what I want. Right, we want to figure out now, so y equals negative 1, or we've got 4y minus equals 3, or 3y equals 4, so y equals 3/4, or y equals 4 over 3. But let's have a look at what y was. Y was equal to sine squared of x, and we're looking for real solutions. So from this one, there's no real solutions. Okay, because sine squared x equals negative 1 has no real solutions. Sine squared of x equals 3/4 is looking promising. We're going to come back to that one. That's going to have some solutions. And lastly, sine squared of x equals 4 over 3 has got no real solutions because sine of x is between negative 1 and 1. Right, so its square will be between 0 and 1, so it can't be equal to 4/3. So what we've got to go with is, what are the solutions to this equation here? Sine squared of x equals 3/4. So you can see we've done all of the hard work. So let's now look at getting back to solutions for x. Right, we've got our 3 solutions for y, right, and now our solutions for x are that sine squared x equals 3/4. So sine of x is going to be equal to plus or minus the square root of that, which is equal to root 3 on 2, or negative root 3 on 2. we need to think a bit more about this one though, because we've got this. We've got sine of x is equal to the square root of y. So sine of x must be greater than 0 because square root of y means the positive square root of y. It's not this. We're not told this. Okay, so that's not a solution. So what we're down to is just that sine of x is equal to root 3 on 2. So let's think about what our solutions are to that. Here's my badly drawn sine curve. Okay, so the principal solution is going to be x is equal to pi on 3, but we want to get a general solution for that one. Okay, so it's going to be this one, this one, this one, this one. I'm going to try and squeeze that in on this slide. So my general solution will be that x is equal to n pi plus -1 to the n pi on 3, right, as we did with general solution. So that's how we can pick off all of those points there in both directions. Okay, so I guess it's quite a step up from 1a of that question, and it does need you to have a look at those equations and just see that sine squared plus cos squared, sine squared of x plus cos squared of x equals 1 is going to help you with that. If you don't see that, the question's going to be impossible. So the exam advice here is not to rush in as soon as you get in there. I know it's tempting when you're doing a high pressure exam like this to think you've got to go as fast as you can, but it's worth taking a deep breath and just reading through the equation and letting things that you kind of know intuitively by now just hit you before you start trying to madly substitute the square root of y or sine x. Right, so that's the advice for today. And for getting to the end of a very long video, there's a prize for the first Onslow student who figures out which song this is. If you let me know, there'll be a chocolate fish.